We have this kind of long-term view about how broadly this eventually scales machine learning to a size that it couldn't possibly be in the centralized world. But initially, it just gives the ability for a machine to unlock financial value from the information it's able to create. And in our view, that's the kind of first step of sovereignty for a machine. In the past, people might have heard us talk about the kind of marketplaces for compute and things like that. All of those still sit behind what we do. But actually, if a machine is going to pay to access compute, it has to have some money. It has to have some kind of financial ability to do that. And what does it have to trade in return? Information. That's the only thing it can trade. And so Delphi, long term, is a huge open market for information. Short term, it's the ability for anyone, human or machine, to create a prediction market over anything and anybody else to participate in that market.
Hi, I'm Jake Brukhman, founder and CEO of CoinFund. I'm here at ETH Denver 2026 with the CEO of Gensyn AI, Ben Fielding. Ben, how you doing?
Good to be here.
Awesome. So I want to have a short conversation with you about Gensyn in 2026. So Gensyn is the Network for Machine Intelligence. Can you tell us a little bit about what that means and what products are you offering the market this year?
Sure. So fundamentally what it means, we as a company connect together the resources required for machine learning. So when we talk about the resources, specifically we mean compute, data, and information. So compute is the GPUs, CPUs, whatever you're kind of executing a machine learning model on. Data is raw data that exists in the world. So this video, for example, is raw data. And information is a harder to explain thing, but we generally think about it as any extra information that a intelligent entity has added to raw data. So if somebody put captions on this video, that would be information. If somebody labeled the video, it would be information. If somebody detected some pattern in the video or something like that, that's information. And so if you have those three things, basically you can create a kind of intelligent model digitally. Right now in the kind of existing world, we do that with huge companies doing it in data centers by gathering all of those pieces together, kind of combining them in this proprietary format and then building a model and kind of renting access to that model to other people. Our view is those three resources originate all over the world. They originate with people, they originate on all of our devices. As we kind of interact with those devices, as we use technology, we are generating those resources as humans. And the kind of old world paradigm that we then give all of that away to these companies so that they can build models and sort of sell access back to us doesn't actually make sense in the grand scheme of machine learning in our view. Machine learning is incredibly powerful as a technology. The more it scales, the more powerful it gets. And we believe as a foundational technology that the greatest impact it can have in the world is if it's essentially unleashed and done across every single resource that exists. And so to kind of TLDR it, we build programmatic technology to connect those resources. So the idea that any individual could actually be part of a large scale machine learning model training run or inference run or anything like that, it doesn't need to go via these kind of gatekeeping companies that sit in the middle currently. And we saw this kind of before with the early internet, right? Like we could have built that to be purely proprietary access via certain companies, but we didn't. I think most people would agree that it was much more successful that we didn't. It created this ability to communicate across the world that everybody has access to. We think the same can be true of machine learning as a technology.
Fantastic. And let's talk a little bit about the products you're launching this year. So in April, you have a product called Delphi going to mainnet. Tell us about Delphi. What does it do?
Absolutely, yeah. So mainnet launch in April, like you said, the flagship app will be Delphi. Delphi focuses on the information portion of those three resources. So our intuition is that information has value in the world. That information currently is traded through kind of lots of different mechanisms. Ultimately, underneath all of them are the financial markets. And so within the financial markets, if I have information that I think other people don't have, I can essentially take a position which bets on that information in a way. So I gave an example in an article I wrote recently around space. So if I believe that there is a large amount of natural resources in a set of asteroids, and I also believe that the technology is either there or almost there, that we can get access to those resources, I could make a bet on the companies that have that technology. I could buy kind of equities in those companies and take a position because I think that I have this information that others don't have. In doing that, I'm both trading that information, so I'm turning that information into money with a certain level of risk, but I'm also enabling those companies to have more resources to go and do that thing, thereby forcing kind of humanity's progress forwards because of the information I have, because of my belief. And so actually, if you think about it, the entire world essentially runs on this. That's how we kind of not force, but how we kind of push human progress forwards. But right now, it's only really humans that can do that process. Machine learning models are essentially huge information machines. That's what they're good at. They're able now to generate information in many kind of abstract scenarios. And so with Delphi, essentially what we're doing, and this is a kind of longer term view, and I'll give the sort of like short term how it works as a product afterwards. But what it essentially does is give programmatic access to a version of those markets. It basically says that anybody can create a prediction market. So any kind of thing that you can think of in the world, simple examples like when will that construction outside finish? Or bigger examples, longer term examples of like when will we mine an asteroid, or who will be the first person to mine an asteroid, or something like that. You can construct these positions, and then others can come and they can take positions within that market, and they can trade that information, that alpha that they have. Behind the scenes, once these markets get to a certain size, they're essentially a proxy of the financial markets, because the liquidity that exists in the financial markets can be behind these markets as well. And so it becomes this user interface to trading information, which rather than just being accessible to humans, if it's programmatic, if it's on-chain, and if it's fully permissionless, is actually accessible to machines as well. And so we have this kind of long-term view about how broadly this eventually scales machine learning to a size that it couldn't possibly be in the centralized world. But initially, it just gives the ability for a machine to unlock financial value from the information it's able to create. And in our view, that's the kind of first step of sovereignty for a machine. In the past, people might have heard us talk about the kind of marketplaces for compute and things like that. All of those still sit behind what we do. But actually, if a machine is going to pay to access compute, it has to have some like money. It has to have some kind of financial ability to do that. And what does it have to trade in return? Information. That's the only thing it can trade. And so Delphi, long term, is a huge open market for information. Short term, it's the ability for anyone, human or machine, to create a prediction market over anything and anybody else to participate in that market.
So this sounds like an invitation to talk a little bit about AI agents. Obviously, Q1 2026, we're living in a time where agents are proliferating. They're becoming smarter and smarter every week. OpenClaw recently surpassed 200,000 GitHub stars and got acquired by OpenAI.
Yep.
So are you anticipating that AI agents will be using Gensyn, and in particular, this kind of information market that you just described?
Absolutely, yeah. We think there's a way of thinking about it that's very like AI centric, which is actually markets are an optimization function, essentially. They're driven by a kind of relatively simple set of primitives around just maximizing kind of value gain. But underneath it, that is a search process. And so if you look at that process, you can see it like operating across the human world. It can operate across the machine world as well. And so it both locally incentivizes these agents to provide information to the machine in exchange for the resources to continue to exist and to continue to proliferate. But also, as they see other information flow into the system, that becomes something valuable for them to learn on. And so an AI agent that comes and interacts with the system, it has some information that it wants to trade, will trade that information, and then it will look at it and it'll say, in order for me to continue to trade information here, I need to be the best I possibly can be. There's a lot of information in the system. I will continue to update my weights and kind of my databases that I access in order to be the best at this system. And so it actually becomes a kind of owned by no one optimization system for the proliferation of the intelligence of AI agents. So in our view, they are the first class citizens of the digital kind of programmatic information markets of the future. But humans bootstrap these systems like they always do. And
right. So that begs the question, like some people think of AI agents as acting on their behalf, and other people think of AI agents acting autonomously on their own behalf. I think both of those things exist in the market today.
Mm-hmm.
But what percent of the future agents will be autonomous, do you think?
That's a really good question. I think so you and I spoke before this. I have a bit of a kind of bugbear with the term agent because it's so overloaded. And one of the issues I always have with it is the anthropomorphization of it, where when we talk popularly about agents, we kind of mean this like pseudo-human entity that you interact with. The definition I always use for agent is basically just like something that operates within an environment and is able to take actions against a certain state. And that entity, it becomes agentic. There's a threshold that you could argue about, but it basically becomes agentic when it's able to execute without explicit instruction for every step, essentially. I think all technology will move in that way. I think basically we're expanding the environment that these systems can operate within, and that will be applied at every stage of the technical stack. So when you and I use software, the UX is going to be dynamic to our use. That will happen because behind the scenes, the system that we're using is able to operate within a wider environment and infer what we're talking about. We could say that's an agent, but we could also just say, hey, it's just the next evolution of software or technology. It's like all going to be agentic with that definition. When it comes down to that like kind of autonomy versus not autonomy piece, I generally bucket AI into three different categories: autonomy, augmentation, and ambient AI. I think that they're reasonably popular categories. Autonomy is that sort of like truly autonomous piece. To me, it means sovereignty. So an AI model that exists without a kind of explicit direction from a human. It's not doing something because of a human interaction. It's actually just existing almost in its own right. It's got some set of rules somewhere that governed its existence. But outside of that, it just kind of continues in perpetuity. And I think you can only have that on crypto rails. You can't really have that anywhere else, because if it was anywhere else, it would go into the second category of augmentation, where actually it's there to do an explicit job for a human. And so I would put kind of all the software UX pieces in that augmentation bucket. Like behind the scenes, they're doing it because the goal is to make our interactions with technology better in some way. Like I'm just using some software. It's kind of changing the menus around because it knows how I work. It's different to how you work. I wouldn't explicitly say that's an autonomous agent. I would just say, hey, that's just better software, basically. The ambient piece is the bit where it gets a little bit fuzzy, because that's like, it's software that exists to serve our purposes, but we probably don't even know it's doing it. It's like the classic example is like an Apple Watch detecting when you fall over and kind of doing something about it. It's like, it's there, it helps us. It's like semi-autonomous, because like I probably don't even know it's there in some of my devices, but it is, and it's like there for my benefit. So I'm still working on my thesis around that. But at the end of the day, I think all software will become agentic by that first definition. And then that autonomous piece, I think, will grow, but it's very unclear how that will actually present itself to the world. What I don't think it will be is this idea of humans task managing many different agents personally. And I think this is probably a pretty heretical view in our circles, but I just don't think humans are broadly very good at that. Some are, most aren't. And so actually, I think most humans' interactions with AI will be via the augmentation path.
Gotcha. So I just want to cover, so Ben, I just want to cover one more product that Gensyn's working on, and that product deals with reproducibility. So can you tell us what reproducibility means and why it's important in this AI machine learning context?
Absolutely. So that product is it's named the reproducible execution environment, a little bit like TE, but specifically focused entirely on reproducibility. And reproducibility in our definition is determinism, which essentially means if I execute a set of instructions on a CPU, GPU, wherever, if I execute that once and then execute it again, it is absolutely identical between the two. So I could have a linear set of instructions, just a set of like mathematical operations, for example. Out the end of it, I get a value. That value needs to be bitwise identical along with every single step along the way. In some ways, this already happens in a lot of computation. In others, it doesn't, because just translating the theory, where it's perfectly possible, to the hardware is quite difficult. We have standards, the IEEE standards, etc., for doing this, but they're fuzzily implemented on hardware. But on the same hardware, typically it's possible. Across different hardware, it's broadly not possible for parallelized computations. And this presents a problem when you want to have any kind of trust with the execution of those operations. Within machine learning, because you need access to parallelized hardware, it gets very, very difficult to establish trust. The crypto world's pretty familiar with establishing trust. In a world where you don't trust anyone, you can construct kind of synthetic trust through consensus. The only way you can achieve consensus is knowing that the kind of process that has happened on one device can also happen identically on many devices, and you can construct quorums, etc., on top of that. And that's how we get blockchains. It's how we get the resolution of decisions, etc., on the EVM and in other places. That's very, very valuable, but it's also valuable in places where you can't just distill something down to just sitting within the EVM. And that's where machine learning computations come in. If we want to trust the execution of a machine learning computation, at the end of the day, we can construct all these complex kind of mechanisms to make it more efficient, but you have to have a form of reproducibility underneath it for any of those constructions to work. And so the crypto world typically extends consensus to other situations using game theoretic security. This idea that if an entity stakes a certain amount of value, that value could be slashed if they misbehave, they can be rewarded if they don't misbehave, etc. And you can terminate all of that within the EVM or within the kind of execution system of the blockchain to have that final decision. And so if I find once I've terminated the kind of decision all the way down to the chain that you misbehaved, I can take that value off you. That's okay in the human world. In the machine world, we need some way of doing that trace to go from machine learning execution back down to the EVM. And we've kind of thought long and hard about how you do that. We've constructed these game theoretic mechanisms, but underneath it all is reproducibility. So that's the blockchain angle. This separately has a lot of value in the kind of normal Web 2 world as well. So when we come to execute machine learning operations, sometimes we need to verify them. If you are doing a new paper where you've defined this new way of doing machine learning training, and you say to the rest of the world, hey, everyone, this way of training is better, everyone has to check and see if it actually is. And in the machine learning research world right now, it's very hard to actually reproduce somebody else's research. Most of the time, you can reproduce it roughly and get kind of the same results, but without full deterministic execution, I can't know for sure that you actually got the results you said you did, or whether you've just kind of massaged the numbers a little bit to prove your point. And this kind of breaks down academic research, basically. You could do it deterministically if you fixed all the seeds and I used your hardware to rerun the thing, but that's not how the world works. I have different hardware to you. How can I do that reproducible check? So using RE, you can actually do it. So all you would need to do is when you do your final training run or your kind of experiments or your proof, you execute those through our reproducible execution environment. And then when I reproduce it, I do the same, and we would get exactly identical results. And that allows me to check your work, and we can have the peer review process execute properly. There are other places where this is valuable as well. If you look into finance or healthcare, etc., we have this black box problem with machine learning where somebody will construct a machine learning model which can do a process way faster than we currently have systems to do it. The problem with that process, though, is when you put it into a highly regulated environment, you can't inspect what's actually happened. And we need to inspect the decisions so that we can actually trust that execution. If we can't go in and inspect the series of kind of processes that led to the decision, we can't be comfortable enough in current kind of society to actually allow that to like deal with healthcare or pharma or finance or insurance or heavily regulated industries like that. With RE, you actually have the entire execution graph fully deterministic. So if you need to step into that graph and inspect any kind of leaf node, any portion of that graph that actually drove the decision that came out of the end of the model, you can do that. It's expensive, which is a reason why a lot of people have said it's not worth building, but certain regulated industries, it doesn't matter how expensive it is. It's wildly valuable for them to have that, and they just haven't had this before. And so it's valuable there. The final place it's valuable is specifically in machine learning training, where when you want to parallelize machine learning training, if we look at reinforcement learning, when you're doing on-policy learning, what you want to do is parallelize the generation of rollouts within models. And so you have a model, you want to essentially search the space of potential rollouts of that model, find the really valuable ones, and then train on those rollouts. Right now, you can do that in a linear way. You could just run it on your device. Every rollout you generate is exactly on policy, which means it was generated by the policy, which is kind of being trained as it runs. If I run that same model on my hardware and it's not deterministic and exactly identical to yours, you're technically not generating an on-policy rollout. I'm generating a rollout which is on policy for me, but if you wanted to train on it, it's slightly off policy. And that, it doesn't make a huge difference in the early days, but in the long tail of training a model, it makes a huge amount of difference because you're not actually on target anymore. You're slightly off target. And so as we progress towards further and further progress in machine learning, we don't want to be slightly off target. We want to be fully on target. And so if you took a very large scale distributed reinforcement learning training run and you ran one with RE, where every single model is executing within RE and is bitwise identical, and you ran one where all the models are kind of roughly the same, but they're not because they're not using this execution environment, you would theoretically get much better performance from the RE model because you're doing true on-policy learning. It's something that Thinking Machines have talked about as well in their blog posts and things. They talked about the theory of a system that could do this. We've already built that system, and so it'll be going live very, very soon. People will be able to train within RE. And again, it's one of those use cases that it's nothing to do with crypto. It's purely in the machine learning training world, and it's how you get true on-policy learning in a distributed setting.
Awesome. Sounds like a very serious piece of technical machinery there. Ben, thank you so much for the chat today. And where can people go to find information about Gensyn?
So just at Gensyn AI on Twitter, at Ben Fielding is me on Twitter, and then our website, Gensyn.ai. All the information is there, all the kind of paths to go to find more about what we build, the products that we release, etc. You can find it all there in our docs pages, our blog, etc. We've got a lot of writing on these kinds of things as well. So like the prediction market stuff that we talked about, if you want to know more about that, we have some pretty long posts and papers if you really want to drill into the details on how those things work and how they'll work in the future in the information market thesis.
Fantastic. Thanks, Ben.
Thank you.